So you guys, I'm going to start with the example 7. It's product to sum. These are on your sheet. I hope you took that with you. If you didn't, then you have your book as well. These are at, product to sum, bottom right hand corner of your yellow or orange sheet. So in example 7, the directions say rewrite the product, so it's something multiplied by something, as a sum or difference, and they give us this, the cosine of 5x times the sine of 4x. So we're going to rewrite this as a sum or difference. So we can see, going down to the bottom of the sheet, that cosine times sine, this is how it becomes specific. Notice that sine, sine, cosine, cosine, sine, cosine, and cosine, sine are all different formulas. So we have cosine, sine first, which is going to equal this. This is the formula. 1/2 times the sine of u plus v, and we're going to get our u here and our v here in those algebraic expressions. So 1/2 sine u plus v minus the sine of u minus v. So we're just going to start plugging and chugging. So here we go. We're going to end up with this. 1/2 the sine of u plus v would be 5x plus 4x minus the sine of u minus v, which would be 5x minus 4x. And then simplifying that. So we get this. 1/2 sine of 9x minus 1/2 the sine of x. And that would be our final solution. So let's go ahead and try number 71. We can just do it together here. Or you guys try and come back and we'll talk about it. So this is, let me look. I'm comparing to see if this is exactly the same as the one we just did. Actually, we did cosine sine, and now we have sine cosine. So we're going to use our different formula, which is 1 up from the bottom. Let's go back and, never mind. Okay, so the bottom, second from the bottom, sine u cosine v. So our u value this time is 5 theta, and our v value is 3 theta. So we're going to simplify by placing that into our formula. 1/2 sine u plus v, so we would get an 8 theta. And now because it's sine cosine, we're going to do the addition, and it's sine u minus v, which would give us 2 theta. And I don't see how I can go back. I hope that I did that correctly. Sine cosine is plus in the middle, and that's what we're doing here. The one that we just did previously is cosine sine. That should have been a minus in between. It would look exactly the same, but just the difference of the two if this had been cosine first and then sine. So I hope I did that correctly. If not, please go back and change your notes. So we're going to simplify this. So our final answer, sorry about that, is 1/2 sine of 8 theta plus 1/2 the sine of 2 theta. And that's our final solution for problem 71. And on the bottom of page 388, it says, sometimes we find it handy to reverse that process, and your sum to product is right above your product to sum on your yellow or orange sheet. So you can see the sine of u plus the sine of v. Sine of u minus the sine of v, cosine u plus cosine v, cosine u minus cosine v. All of those have a specific formula. So let's go through example 8. It says find the exact value, and you guys are catching on now. Anytime it says find the exact value, we know that we are leaving it in radical form. We are simplifying and leaving it. We're not plugging it into the calculator and getting decimal. So notice if we want to check this, we should be in degree mode. To find the exact value of cosine 195 plus cosine 105, we are going from a sum, cosine plus cosine, to a product. Here we go. Cosine plus cosine is equal to 2. You can see this on your sheet. The cosine of u plus v, so we're going to do 195 plus 105. That should give us 300 over 2, check my work, 200, 300, yep, that's right, times the cosine of u minus v, 195 minus 105, which should give us 90 degrees. So 90 divided by 2. Now we're going to simplify that further. This is 2, and the cosine of 150 would give us negative square root of 3 over 2 on our unit circle. And the cosine of 45 gives us square root of 2 over 2. And we find that product, we get 2 times the negative square root of 6 all over 4. These guys cancel. We get negative square root of 6 all over 2. Final solution and exact solution. So go ahead and try problem 85. So you see a solution here. You can stop if you need to look at it. We did basically the same thing we did, except this time our sum to product was sine u plus sine v. We plugged it in. Not too many differences. Looks very similar. And we came up with the square root of 2 over 2. And so looking at example 9, it says we're going to solve a trig equation. Before we were just using a formula to find the exact value, but now we're going to solve for those intervals on the unit circle where we see our expression equal to 0. So in this we've taken the sum and we're moving it to a product, so sum to product of sine u plus sine v. We've written that out. We're going to simplify that. It's 2 sine of 8x. 8x over 2 would give us 4x. And the cosine of 5x minus 3x, 2x over 2, would give us x, equaling 0. So what we can do right now is divide both sides by 2. That gets rid of that. So we have the sine of 4x equal to 0, because 0 product's property, or the cosine of x equal to 0. Well, the sine of anything is 0 at 0, pi, and 2 pi. Pi. So 4x is equal to pi. We did one of these in class on Wednesday. Therefore, x is equal to pi over 4. So then 2 pi as well. So all increments of pi over 4. So, and n pi over 4. Sorry, just kidding. They wanted us 0 to 2 pi, not including 2 pi. So we would stop at that point right there. So let's go on to solve the other one. Let's see. Sine of x is 0 at 0, pi, and then 2 pi. Did I remember that correctly? Yes. We're not going to include 2 pi. We're going to stop before it. Okay. So here we go. Where's the cosine of x equal to 0? The cosine of x equals 0 at pi halves and 3 pi halves. So x is equal to pi halves. It's not a multiple angle. And 3 pi halves. In the book it says this. We did include the 0, just not 2 pi. So we have sine of 0. So this would include 0 and pi fourths, and we have pi halves and 3 pi halves, and we know we have all increments of pi fourths. So we would have 0 pi fourths, 1 pi fourths, 2 pi fourths, 3 pi fourths, all the way up to 7 pi fourths, just because we know every one of those is an increment or one of the values we're looking for. So let's try problem 89. So in 89 we know that we're going from a sum to a product, and I've picked the one that we need. Sine plus sine is the first one on your sum to product list. So I've broken that into 2, sine times cosine, and we see that our u and v, 6x and 2x, 6 plus 2 divided by 2 gives us our 4, and 6 minus 2 divided by 2 gives us our 2x. Dividing both sides by 2, we just get the sine of 4x equals 0, or the cosine of 2x equals 0. So basically very similar to what we've already done. So 4x, where's the sine equal to 0? The sine's equal to 0 once again at 0 and pi, and all increments of those. And then we have the cosine equaling 0 at pi halves. So 2x equals 0 at pi halves and 3 pi halves. So in order to solve this, we are dividing both of these by 4. So it's 0 over 4, which is still just 0, and pi over 4. So those are our two answers to solve for x. Over here we're solving for x again, dividing by 2. X is equal to pi halves. 2x is equal to pi halves. So x is equal to, dividing both by 2, we would get pi over 4, and we would get 3 pi over 4. And 89, I don't see that answer either. I'll go check that and make sure we're good. And so when we talk about these solutions, remember this, we're talking about all increments. If I talk about 0 plus n pi, we get 0, 1 pi, 2 pi. So we can see that that is included because those are going to be included. They just are. So it's pi fourths also plus n pi over 4. So all quarter turns of that circle are included. All of our answers would be 0, pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, you're getting the idea, 6 pi over 4, and 7 pi over 4. And I believe that they asked us to stop at 2 pi. So there's the finale of Chapter 5. That's the second part. And you guys should be good to go. And I'm going to get back on here and go over the second part of 6-2.